Okay, algebra students, today we are going to learn about solving quadratics by factoring. One of the really unique things about solving quadratics and that we learned with graphing is that we set these quadratics equal to 0. Here's a couple of examples. We have x minus 7 times x plus 2 equals 0. So here, this quadratic has already been factored out for me. So I'm just going to set each one of these factors equal to 0. So x minus 7 equals 0. I'm taking my first factor and I'm setting it equal to 0. And x plus 2 equals 0. So now, if I want to know what my two zeros are, I just solve these two equations. And these are fairly simple. Add 7 to each side. So x equals 7, and subtract 2 from each side. X equals negative 2. So what are my two zeros, or what two numbers make this quadratic true? When x is 7 and when x is negative 2. Here's another one down here, and this one looks a little bit different because one of my factors is just simply x. So I'm going to set each of my factors equal to 0, x minus 2 equals 0, and x equals 0. Well, that was fairly simple. I already have one of my answers, x equals 0. I just have to add 2 to each one down here, x equals 2. And we can actually check these by plugging them back in. So I could say 2 minus 2 times 2 equals 0, where 0 times 2 is 0. Yes, so 2 works, and then of course 0 times 2 is going to give me 0. So let's look at one where it's not already factored for us. Here we have a quadratic. We need to factor this out, so you can set up your x and your t if you need to and think about what multiplies to give us 8 but adds up to give us negative 6. Well, I notice I have a negative in the middle here and a positive at the end, so both of my factors are going to be negative. It's negative 4 and negative 2. So what are my two factors for this quadratic? My factors are x minus 4 and x minus 2. Now I take each one of my factors and I set them equal to 0. So I have two equations that I'm working with. Here, x is equal to 4 and x is equal to 2. If we were to take both of these answers and plug them back into our original quadratic, we would indeed get the answer of 0.
Okay, so here's our last example. Negative 2x squared equals 20x plus 50. What we've learned so far is that we cannot solve an equation until it equals 0. So I'm going to go ahead and add 2x squared to each side. So I get my equation to say 2x squared plus 20x plus 50 equals 0. You cannot start factoring, graphing, solving using any method until your quadratic equals 0. Now I'm going to factor this. So I look at my three terms and I'm going to notice that I have a greatest common factor. Remember, that's where you always begin. So I'm going to factor out the greatest common factor of 2. I'm left with x squared plus 10x plus 25. Okay, now I'm going to take that trinomial right in here that I was left with and factor that. I noticed there that x squared is a perfect square, 25 is a perfect square. That's a perfect square trinomial. So I can quickly factor that into x plus 5 times x plus 5. All right, so I'm just copying down my problem. Now, if you didn't notice that as being a perfect square trinomial, you go ahead and do the t and the x, and you would end up with the same answer, just take you a little bit longer. Now, I have three things here that I'm going to set equal to 0. I'm going to look at these. The first thing that I look at is 2 equals 0. Does 2 equal 0? Definitely not. So this 2, greatest common factor that we factored out, has no meaning to us anymore. That's not part of our solution. So now I just take the x plus 5, set that equal to 0, and my second binomial, which was the same thing, x plus 5 equals 0. When I solve this problem here, I get x equals negative 5. That's the exact same thing I would get when solving this one. So since they're the same, I don't need to write them two times. It doesn't make sense to say x equals negative 5, x equals negative 5. My one solution to this problem is x equals negative 5. So if we graphed this quadratic, we would see that this is one of those graphs that only has one 0, and that is x equals negative 5. Alrighty guys, that is it. I'll see you later.